A very good morning to all of you. Today we are going to discuss a very important topic related to data transfer instructions. Here we will be discussing instruction format, constant operators, arithmetic operators, and the features of move instructions, right? And then we will be going to discuss about this particular table and the interchange of instructions from one memory location to other memory location. So first we will be discussing a particular format in which we are having a mnemonic, operand 1 and operand 2. Mnemonic is somewhat like add, okay, SUB, subtract, or you can say move instruction, or any type of operation you can have, right? So these all come under the category of a mnemonic. A mnemonic can consist of one operand or two operands. If you are having two operands, it is separated by a comma. And if it is having a one operand, there is no comma, okay, only one operand is there, mnemonic, operand, or you can have no operand, right? If you are having two operands, you can have a simple comment that the content of one register is transferred to the content, is transferred to other register, or we can have second operand. Second thing is that the mnemonic operand, only one operand is there, right? It means that the content or the operation will going to add, or you can say that the data transfer is going to take place into the accumulator, right? From a particular register, because we are having one operand. And if we are having no operand, the activity will be in an accumulator, because accumulator is the main main storage device in the entire architecture. Okay, so this was all about the format. Operand 1, operand 2 separated by a comma, one operand and no operand. Next is the constant operators. In constant operators, we are having a binary B, octal O, hexadecimal H, and decimal D. Right? So here we can convert any type of data into any type of respective format, whichever you want. Right? If you want your data to be stored in a binary format, you can write B, you can write O, you can write H, you can write D. Right? Next, we are having the arithmetic operators like plus, minus, division, and multiplication. Logical operators like AND, OR, NOT, XOR, NAND, or we can have other logical operations also like NOR, second universal gate. So we can say that a system or a microprocessor is a kind of a device through which we can send our data within the CPU or between the CPU and the main memory, right? And we are having other transferable things also to transfer data from register to register, from immediate operand to the register, immediate operand to the memory location, register to memory location to register, or we can have a register or a memory location to a segment register. We can have a category to transfer data from one memory location to other memory location, or from one register to other register, or from immediate operand to register, right? Or from immediate register operand to memory location. Or we can have a transfer from register to memory location into one of the segment registers. Here we are having 4 segment registers: code segment, data segment, extra segment, and stack segment. We have discussed in the previous lecture. Now this is a kind of a table in which we are having a proper name, a proper full form of a mnemonic, and a format for this particular full form, and a description or a comment. For example, the very first name is move, MOVE. This is the proper name. This is the mnemonic MOV, and here we are having a destination DST and SRC. It means that operand 1 and operand 2. We are having two operands, two registers, source and destination. The description will be the source is transferred to the destination DST. Just look the direction of arrow. It is coming from source. Likewise, we are having load effective address. If we want our address to be load from source to any register, we can have this particular format, from source to a register. LDS with pointer, right? load ds with pointer, it means that the data segment register is being pointed from one to the other memory locations, that is increment by 1, increment by 2, increment by 3. Likewise, we are having extra segment register also with pointer, LES register source is transferred to the register and the ES is incremented by 1, right? And it is कोई hard and fast rule नहीं है कि whether we are having 1 or 2, we can have 3, 4, 5 depending on the situation. The final thing is that the exchange operation, XCHG, register 1, register 2, you can have a direct interchange of data from register 1 and register 2. You can have a bidirectional arrow. In all these descriptions, we are having a single direction arrow, but in this we are having bidirectional arrow from register 1 to register 2 or from register 2 to register 1. Also, we can have an interchange of contents with the help of coding. Like we are having two 8-bit registers, AL and BL, and we are having two registers, operand 1 and operand 2, right? And these are the steps 1, 2, 3, 4. The very first step says that the operand 1 is transferred to AL. The content of operand 1 is transferred to AL. The content of OPR2, yani ki register 2 is transferred to BL. Now OPR1 and OPR2 is empty. So the content of AL is transferred to OPR2 and the content of BL is transferred to OPR1. Right? So in this way we can interchange the content of any register to other register. Right? AL, BL, likewise we are having AL, BL over here, we can have other registers also. Okay, so you don't have to write the entire coding for this interchanging the contents. You can have directly. You can write directly XCHG AL, BL. Right? Through this we can transfer. We can have the transfer of instruction, transfer of data directly from BL to AL and from AL to BL. So this was all about the data transfer instructions. In which we have discussed instruction format. Mnemonic is there in operand 1, operand 2. Two operands can be there, one operand can be there, no operand can be there. The constant operators, binary, octal, hexadecimal, decimal, and here we are having your arithmetic operators, addition, subtraction, division, multiplication, and the logical operators like AND, OR, NOT, XOR, any other logical operations also like NOR, XNOR, NOT gate, right? Here we are having some basic categories to transfer data from one memory location to other memory location or from one register to other register. We are having some categories. Also, to segment registers also we can transfer directly data from register to memory location or from memory location to register. These are some basic phenomena through which we can transfer data from one location to other location, from source to destination. We can have transfer data from we can have the effective address also. We can have the DS data segment with pointer, extra segment with pointer, and we can have a direct relation to transfer to interchange the data from one register to other register. EXCHG we can use this directly to transfer the content from one memory location to other memory location, right? We can interchange. Okay, so this was all about the data transfer instructions. In my coming lectures, we will be discussing more about different instruction formats, arithmetic operators, binary operators. Okay.